Welcome back to our research series in human-centric robotics. Today, I've decided to do a short video and explain our robots, what robots we have, and tour the Robotics Institute at UTS. Anyway, so today I will start the video in Winter Garden here, and then I'll walk through the places and then walk through our robots and in Robotics Institute. So before that, let me show you our kitchen area. So usually we sit here. It'll be really crowded, and we sit here. We discuss. We eat some food, socialize. It's a nice place to socialize. And this is the lab we have, and I'm working in this area. I'll show you that space, and I'll show you some other examples of successful projects and also the projects that are currently ongoing. So let me go to the lab. So usually when we do touring, when there is high school students or visitors coming to our lab, I usually take the responsibility of being the lead, leading the tour. And usually I go along with the robots and explain what projects we do at UTS and what kind of capabilities our robots have. So let me introduce the space first. So first of all, the lab is separated into two main parts. Most of them are human-robot collaborative projects, but also I'll introduce some of the work that other colleagues in Robotics Institute are working on. So let me introduce this robot. So let me start from here. So this kind of robot is called collaborative robot, and for short we call it as a cobot, but it is universal robots. We call them URs. This particular one is UR10, and then there are smaller ones which are UR5 and UR3. And then they attach a camera here. They have a camera attached to the end effector, to the arm, and then they try to identify how to move this shape into the desired space correctly. The objective there is actually human demonstrates a task and how robot performs the task as human demonstrated. So they do this, they collect data of camera images, and they collect the trajectory of human demonstrations, and they map into the robot's decision making. This one is a Fetch robot, basically designed by Fetch Robotics company. It's quite old robot that we use, and it's not that popular nowadays compared to this kind of collaborative robotic arm. But this robot is being used for research purposes for quite a long time because it has a camera and you can attach a microphone through USB. And also you can do all sorts of like arm trajectories as you want. And also there is a base that has wheels, so it can move as well. Okay, so let me introduce this one. Again, this robot is UR10 robot. So good thing about this is that you can buy these robots online, and then you can attach to any kind of device on the end effector here, so that it will perform tasks desired. For task, it becomes a task-specific robot. This one, we attached a custom designed holder, and then we attached the drilling mechanism. You can buy this drilling mechanism, you can buy the arm, and we 3D print the holder parts. Then we attach a drill to drill the screws. The idea there is that imagine in the construction environment, there will be lots of screws to be drilled, and the screw length can reach to up to this length, even a longer length. So imagine you as a worker trying to screw this nail into the wood, And you will be doing that as a construction worker for 100, maybe 200 times a day. And imagine you're doing that for 10 years. It's like ergonomically problematic, and basically the worker has to retire early. So the idea there is, instead of replacing the construction worker, let's take that physically demanding work and use the robot to take over that physically demanding work of drilling. Plus, this robot will do the drilling task accurately and consistently, and it's quite reliable as well. So what happens here is that we attach these long nails on the tip of this arm, the drilling mechanism, and then human pushes some button here, identifying where to drill, and then the robot will drill to that space, to that location, in a constant speed, more reliably and straight. So let me show you how we move this robotic arm. So we move the arm with so-called as admittance control. For example, in this robot, which is I particularly used in my previous experiments, is similar robot, but we have this admittance control, which means that I can control all the joints of this robot without explicitly moving each joint. For example, if I want to move this arm, which is heavy, and instead of me spending a huge amount of force and effort, I can just push the button here, and then with my tip of my fingers and with a little bit amount of force, I can move this arm smoothly. So that's the idea, and the advantage of that is that if I imagine these tiles being heavy tiles, if the tiles are sucked in here, and then I'm lifting the tile, I can give small amount of force on the tip of this robot, and I can lift the heavy stuff. This is the outside view. So this area is alumni garden area at UTS, and this one is a famous UTS tower building. And this is a spot that I usually work. So these ones are construction robots I've explained. Now let me explain the robot that matters in the hospital environment. So for example, if the patient is unable to move physically by themselves, then the nurse has to lift the patient. And for example, there's a daily requirements of going to a toilet or somewhere else, then the nurse has to lift the patient. It's a physically demanding act. And then we ask a question, why not do that by using a robot? And here we designed this Hoist robot. So what happens here is, imagine a patient laying down here, and then nurse will put this under the patient and then give a command, then the robotic arm will lift. So right now what we're doing is we're trying to make this robot more intelligent, more adaptable to each patient, because every patient, every nurse is different. And this robot, with our AI capabilities and intelligence, we want to attach those kind of features to the robot so that it becomes not just a tool or that can be controlled with a joystick, but also it can act as intelligently. For example, if the patient is not lying correctly, then the robot can say from the camera detection with the machine learning or AI, can say to the nurse and help assist to the nurse, saying, look, the patient is not laying correctly. So those kind of small tasks can be applied and made a robot a more intelligent robot. So that's what robots we have. So far, I explained the construction robots and robots that are quite old but still useful to do certain tasks. The Hoist robot that I'm going to do some experiments in the future, near future. And right now I've done some experiments with this robot. We call it CanBot. And we have obviously the drilling robot that minimizes and reduces the physical burden of a human. Here we are not replacing the construction worker. actual construction worker will adjust where to drill and push a button, and then robot will drill that accurately, reliably. That's the point. And in this part of our lab, we have other projects that's not directly related with the construction. So when there will be visitors coming from high school or investigators or primary school students, they are really interested in this cow. So this is a finished project. So this is not a robot, it is just a plastic cow. The goal here, the project was that in the farmland, to make sure that the cow is ready to be killed, the farmer has to make a decision whether the cow has enough fat, enough meat. That decision could not, it was a subjective decision, obviously. That depends on the experience of the farmer. But we asked the question of how can we use robotic knowledge and give that high-level decision command, advice, the farmer. Another robots we have here is the medical application robots. So what happens there is that the surgeon comes along and drills the bone to remove the certain parts, and then attach a hip replacement device, like metal device like this. But as you can imagine, that drilling requires experience, expertise, and also the consistency in it. So that's again the perfect case for a robot to have, because it's reliable. It's reliably drills in a hole a certain amount of thickness that a surgeon is decided to do, and then it will do the task consistently every time. That's the advantage. And then the researchers in this project were successfully integrated this robotic task, and now they are collaborating with the hospital, with the doctors and surgeons to decide on what could be improved. For example, they developed and added as a contribution the different type of a sensor. Previously, in a similar act, the sensor is much bigger sensor. Now they come up with a smaller sensor to use. Another robot that's quite old right now is the robot called PR2. I like this robot because the advantage of it is that it has two arms. It's a fully compact robot. It has a camera. Even though it is quite old, it's fully functioning with the wheels, arm, and the camera, and it could be useful for a lot of different tasks, such as usually in the tours I give example of putting dishes into a dishwasher or ironing. In the case of putting dishes into a dishwasher, you can imagine that one arm can open the dishwasher, second arm will grab the dishes and then put inside a dishwasher. So it's a double hand required task. But also imagine you're doing ironing. Ironing cannot be done efficiently with just one arm. So imagine one arm holding the iron, the second arm is holding the cloth and correcting the cloth. So it's two arms has to communicate and collaborate together to do a task. Or an interesting thing is that lifting a box. When you lift a box, you can see that you need two arms, but one arm is pushing the one side, another arm is automatically compensating that push of force. But for robots to do the task, it has to be programmed. And that's why we have this robot and researchers here working on it to come up with novel algorithms and solutions to make these robots two arms cooperate together and do one task that's efficient enough and do tasks that efficiently as humans do. By this kind of robot attachments and robot developments, each patient can get a special personalized treatment. So it's a patient will give its force to the arm by wearing this, and robot will get certain information from the patient's arm movements, like force, speed, and all the rest, and will decide as an AI decision making which force should be exerted to improve its rehabilitation speed and also improve the arm's dexterity. So this robot is similar again. Imagine in a manufacturing line, you have a human right now identifying which bars are short and long. So which bars are not consistent enough, so that human has to remove those bars from the line of production and manufacturing. But that's again physical burden. Right now, the researchers here are attaching a camera outside here, for example, and observing the bars. Imagine them being metal bars, and then they are designed a special tool attached to the end effector, and then they have a camera that will identify which bar is shorter than the rest. Second, the arm will make a decision on taking the bar and lifting it out from the other manufacturing line. So it's quite interesting to how these robots in our lab are used in the industry. As I said, medical industry, hospitals, manufacturing line, construction tasks, all of them are quite interesting and exciting at the same time to work on. So that's pretty much most of our robots we have. I don't think I missed important ones, but most of them I covered. And when investigators or participants or people, curious people coming to our lab, I usually take the lead and take the responsibility of doing the tour. And pretty much more or less the tour will be similar, but it will take a little longer time because we'll do certain demonstrations of the robots. We'll activate the robots and the robot will do drilling, all sorts of cool stuff, and we show our capabilities to the people who are curious and come to our Robotics Institute lab. So basically this is all from this video. It took a little long, but I tried to be quick enough and I tried to go through almost every robot we have. The idea here is, the objective here is that right now most of the robots I'm not working with. Still, I'm communicating with other researchers in our lab and trying to get some information from their work so that I can explain in the next future tours. Therefore, I try to make a video like this so that there is a physical record of the tour that we do, and also obviously it's a practice for me, and also it's a good record that the other researchers, PhD students want to take over this role later on from me, so that they can watch the video, get some insights. At least it will be a good starting point to watch the video and then doing certain actions. I know it was a little long, but I think it arose some of the curious people watching this video to do some work in robotics. And if you're keen, if you have particular questions you want to ask, feel free to write in the comments down below. So that's all from this video, and hopefully you enjoyed the video, enjoyed the process, and also get a little bit curious on what we do. And thanks for watching, and I will see you soon. Bye for now.